The diagram below shows the location of houses for a village headman H, his secretary S, and the trustee T. Now H is 1.3 kilometers from S, and T is 1.9 kilometers from H, and the angle THS is actually 130 degrees. So here's the diagram. The first question is find the area of triangle THS. So how do you deal with this particular problem? Now, what you need to understand here is, so this is S. First of all, you need to know the proper formula for calculating the area of a triangle. So it is given by area is equal to half A times B times sine C. So this means that when you look at this particular figure, let's say that this side is actually small letter t, and this side is actually small letter s, and this side is actually small letter h. So in this case, AB here is corresponding with the two sides that are making up this angle represented by C. So we can go and replace. This is going to be area is equal to half, and here we're going to have T times S times sine, and this is the angle here, 130 degrees. So we can do the math here. We can say area is equal to half times, this is 1.3 times, this is 1.9 times sine 130 degrees. So if you enter these values on the calculator, you are going to get 0.94606 kilometers squared. And so this is our area. Now the next question is find the distance TH. So this is question 2. So find TS. So this is the distance that we need to find. So how do we find that one? Well, in this case, when you have a situation like this, remember that you have to use what we call the cosine rule. Now the cosine rule is given by a squared is equal to b squared plus c squared minus 2bc times cos A. So remember that this is the standard formula that we are going to use when we are trying to find this particular distance. Now this A is corresponding with the distance to be calculated, and its angle here, cos A, is actually the angle that is made up by the two sides, these two sides which are being represented by B and C. So here we can go ahead and substitute into the formula to get the correct answer. So here we're going to have h, which is the distance to be found, and this is going to be, notice that we have t squared plus, and this is s squared minus 2ts times, and this is cos h. Now at this time we can just go ahead and start calculating. So this is going to be h squared, which is equal to, notice that t squared here is 1.3, so we're going to have 1.3 squared plus, then s squared is 1.9 squared minus, this is 1.3 times 1.9, and this is multiplied by cos 130 degrees. So this is going to be h squared is equal to, Then we can use the calculator to find the value for these figures. So this is going to give us 8.47537. Now at this time we can just introduce the square root to find the value of h. So this is going to be h square root of this answer. So this is going to give us 2.91125 kilometers. So therefore we can say this TS is actually 2.91 kilometers, and so this is our answer. Now what about the shortest distance from H to TS? How do we find that one? So this is 3. The shortest distance from H to TS. So here what we are looking at is the shortest distance from this H all the way to TS. Instead of, if we're moving from H, instead of going through to S and then to this particular point, we can actually go straight from H to this base distance. So how do we calculate this distance here, the shortest distance? Now what we need to understand here is that the entire area of this triangle is dependent on this particular distance, this shortest distance. If we extend this distance, then the area of this particular triangle is increased. At the same time, if we shorten it, then the area of this triangle is shortened. So this shortest distance is actually defining the entire area of this triangle, and therefore when we are trying to find this distance, we always use the formula for the area of the triangle. So the area of the triangle is given by half BH. Now in this case, this is the height that we want to find. We have the base here, TS, and the height. So we can go ahead and make H the subject of the formula, since this is what we need to find. When we do that, this is going to give us BH is equal to 2A. And when we do the math here, we are going to get H, which is equal to 2A over B. So this is the formula that we are going to use to find the shortest distance, which is represented by H. So let's go ahead and do the math here. H is equal to 2, and remember that we found the area of the triangle, which in this case is 0.94606. And the base here is, we need to take the entire distance TS for the base, because that is for the entire area. We've already discussed that this shortest distance is actually defining the entire area. So even when we are getting the base here, we need to get the entire distance here, which we found to be 2.91. So H here is equal to so this is going to give us 0.650 kilometers, which in meters is actually 650 meters. So this is our shortest distance. In the following triangle, PQ is equal to 41.6 meters, PR is equal to 70 meters and angle PQR is equal to 105 degrees. Calculate the angle QPR, this particular angle here. So how do you deal with this particular problem? Now, the best way to find this particular angle is first to find this angle here. When we find this angle here and we have this angle here, it will be much easier for us to find the angle at P. So how do we find the angle at Y? Well, we use what we call the sine rule. Now, the sine rule is given by the formula A over sine A is equal to B over sine B, which is equal to C over sine C. So this means that when we have a side like A, it is divided by the sine of that particular angle, which is opposite to that side. So this A is an angle which is opposite to this side. If we had this side here, if we had this side, would have gone straight into the calculation by just using the two sides here to find the particular angle here. But since we don't have this side, that's why we need to find this angle here first, and then this is going to help us find the angle at X. So this means that we're going to have this side which is Q, and this side which is P, and this side which is R. So in this case we are using these two sides and this angle to find this particular angle at R. So let's go ahead and do that. So here we're going to have Q over sine Q, which is equal to, and here we're going to have R over sine R. Notice that this R is the angle at R here, which we are interested in. So at this point, we can just go ahead and plug in the values into the formula. Notice that Q here is 70, which is divided by, this is sine 105 degrees, and this is going to be, R here is 41.6, which is divided by sine R. Now this first part here is going to be equal to so this is going to be 72.47, which is equal to 41.6 over sine R. So at this point we're going to have sine R multiplied by 72.47, which is equal to 41.6. So when we divide this, we are going to have sine R is equal to 41.6 over 72.47. Now this is going to be sine R is equal to, what is 41.6 divided by 72.47? So this is going to give us 0.574. And so at this time we can find the sine inverse of this particular figure. So we're going to have the sine inverse of 0.574. So when you use your calculator for this one, you're going to get 35 degrees. So this is the angle at R. So here we are going to have 35 degrees. So to find the angle at X, this is going to be X, the angle we are looking for, plus 35 degrees, which is the angle at Y, plus this is 105 degrees, the angle at Q, and the total is going to be 180 degrees because this is the triangle. So here we are going to have X plus 140 degrees is equal to 180 degrees. So x is going to be 180 degrees minus 140 degrees. So x is going to be 140 from 180 is 40 degrees. And therefore, QPR is equal to 40 degrees. And so this is our answer for this problem. Now, what about the area of the triangle PQR? How do we find the area of this particular triangle? So this is the area of triangle PQR. Now the area is given by half AB times sine C. In this case, for us to find this particular area, it's PQR. So obviously this C here, the angle at C, should be this particular angle. But notice that we don't have this side here. Since we don't have this side here, it might be difficult for us to find this particular area because we only have this side and not this side. Because remember, we have to use these sides that are making up this angle to actually find the area of this triangle. So for us to find this area of the triangle, we first need to find this particular side. And at this time, it's much easier to find this particular side because we now have this angle here, which is 40 degrees. So this angle here is going to help us find this particular side. So let's go ahead and use the same sine rule to find this particular side here. So here we are going to have this side P, the sine of this angle, which is sine 40. Remember that the angle at P is actually 40. And we can use this side here, which is A. Notice that it is 70. And this is going to be over the sine of this particular angle, which is 105 degrees. So in this case, we can go ahead and find this particular side. So P is going to be 70 times sine 40 degrees over sine 105 degrees. So P is going to be, and when you use your calculator, you're going to get 46.6 meters. And so this is the side here. Side P is actually 46.6. So now we can go ahead and use the two sides to find the area of the triangle. So in this case, we are going to have the area, which is equal to half times the two sides. We are going to have R times P times sine Q here, the angle at Q. So this is going to be 1 over 2 times, this is 41.6 times, this is 46.6 times sine 105 degrees. So when you use your calculator here, because this is half 0.5 times 41.6 times 46.6 times, and sine 105 is equal to 0.9659. So this is going to give us 938 meters squared. And so this is the area of this triangle. Now, How do we find the shortest distance here? The shortest distance from Q to PR. So the shortest distance from Q to PR. So in this case, this is the shortest distance from Q to PR. So again, this distance is actually defining the entire area of this triangle, which means that we need to use the area of the triangle to actually find the shortest distance. So in this case, again, the area of the triangle is actually half BH. And here, this is the H. So we're trying to find this particular H. And so this is going to be H is equal to 2 area over base. So let's go ahead and find the value of H. So this is 2, and the area is actually 938 over, and this distance here is actually 70. So this H is going to be equal to, so when you do the math, you're going to get 26.8 meters. And so this is the shortest distance. And that is all for this particular question.